In this video, we're going to start something a little bit new, and that's going to be our Riemann sum, our summation notation. And that's this sigma sign right here. We're going to first learn about how it works, and then the end goal is we'll be able to do what's in this picture here by the end of it, which is being able to write an antiderivative integral using the summation notation. And we'll go into a little more the concept of why that's necessary. And so this first one, let's go into our, before we do, I want to do an example of what this is called here, a sigma. And this gives us like a starting value, and there's usually something inside of here like 2y plus 3, maybe something like that, okay? And so what's going to happen is this is going to equal, what's going to happen is we're going to plug a 0 into I. Okay, let's just say that's our first term. Then plus, what we're going to do is we're now going to plug a 1 into I. Then we're going to plug a 2 into I. Then we're going to plug, and you can guess, we're going to stop here at 3. So we're starting, it's called summation because we're adding. And we're going to start by plugging a 0 into our I, and then we're going to work it all the way up to 3 in integers. We're going to go up by integers. So 0, 1, 2, and then 3. So notice that's the last one. Then you just evaluate that. I don't really want to spend too much time with that. 3 plus 5 plus 7 plus 9. And that's going to give us 8 plus 7 is 15, 24. So that's how summation notation works. So think about that a bit. This can go crazy. Notice what we're plugging into is not just any variable, it's the variable specified right here in the summation. There's double summations out there that are, you know, kind of make things get a little bit more chaotic, but this is going to stick a little more to those the basic idea there. That whatever we plug in here will go in there, and we'll just keep adding up in integer increments. So consider the sum 2 plus 5 plus 8 plus 11. So which one of these represents that sum above? So let's try each one. So if I start by going from 1 to 4, if I plug in a 1, I'm going to get 3 times 1 minus 1. So that's for the first one. Plus 3 times 2 minus 1. Plus 3 times 3 minus 1. Plus 3 times 4 minus 1. And this is going to be 2. This one's going to be 5. This one's going to be 9 minus 1 is 8. And this one's going to be 12 minus 1 is 11. So just so we can see that, there you go. Or actually, let's pick something a little brighter so you can see the plus signs. And so that does actually work. Now pay careful attention. This does say choose all that apply. So we got to test the second one, see if it doesn't work as well. And you could also see this is going to start with 2, and then it's just going to go up with increments of 3. 2 plus 5 plus 8. And you can see this one started with started at 1. So 3 times 1 is 3 minus 1 is 2. So this one started at 2, and then it's going to go up in increments of 3. So you can kind of see it before you even start. But let's take a look. So 2 plus 3 times 0. I mean, I definitely recommend that you guys look into those patterns, you know. It's going to make things a little bit easier in the long run if you start finding those patterns. Don't just get the problem over with by making it a process, but look into those things. So 2, that's going to be 2, this one's going to be 5, this one's going to be 8, this one's going to be 11, and we're adding all those. And so that one works out as well. So let's go ahead and look at this next one. So this one, this is what I was telling you earlier. We're just going to plug into I for this one. Just like over here, we're only going to plug into the M. And that's where you're going to get all these J's going on in here, because nothing's going in for J. It's just going to go in for I, because notice this is I equals 0. and that's I. So what would this equal? Let's start with I being 0, so 3 times 0 minus 7j. Then 3 times 1 minus 7j. Then 3 times 2 minus 7j. Then 3 times 3 minus 7j. We're adding all those up, right? And so 3 times 0 is just 0 minus 7j, plus 3 minus 7j, plus 6 minus 7j, plus 9 minus 7j. And I would just kind of, once again, just kind of picture that, what's going on in between those plus signs. And you'll see that that looks like B, right? And this one is just choose one answer. And you can combine like terms if you're actually doing the sum afterwards, but they're just trying to figure out which one does it look like. And there's another example. The next one's where it gets a little more difficult because we're going to use this idea, remember with those Riemann sums, and try to figure out how can we write the Riemann sum, but in that sigma notation.